Alrighty, so for this we're going to do sum and difference identities for sine and tangent. We've already done cosine, right?
Did we?
Yes, that's what we just got done doing. Were you paying attention to warm up? Okay, anyway, so, alright, so now for this one right here, so I have a lot of blah that I'm going to kind of jump through here. So, blah, blah, blah. These are actually, it's important, but I'm not like trying to degrade the importance of it. I'm just saying you really don't need to know this to be able to answer this. So there is a process that comes down to this. This is the piece that you need right here. Because now my new formula for sine, right? New formula for sine, if it goes sine AB, so A plus B, it goes sine A cosine B plus cosine A times sine B. Okay? Now, same thing right here. With the subtraction problem, sine A minus B, 3 sine A cosine B minus cosine A sine B. So, I'm going to put those things in together. So, this is the same thing. I find these numbers from my unit circle. Did I jump too many?
Hey, where you at, man?
Okay, and here's my tan formula. Yes.
So for example, if it says tan, like, what would it be? Like
105?
Yeah, 105. You would use two numbers that equal or that subtract or add to 105.
Yes.
Use whichever one you want.
Yes. It's kind of like exactly when you were doing makeup earlier during warm up. The exact same thing as what was on the board. Okay, I don't know if you can see from that, but yes. Okay, so that you're like for this one it was 60 and 45. Those are the two numbers that are on my unit circle that will combine to actually get me what I need.
Okay. And you just plug in A and B.
Yeah, but tangent's more complicated because tangent's not a number on the unit circle. It's a ratio of numbers.
Yes.
Oh, yeah.
Because we know tangent is sine over cosine, right?
Yeah.
So I'm gonna have sine, which is whatever my
What? Oh.
children.
I'll let you learn
I
that.
was absorbing. Now I'm distracted.
Chipotle.
I was like, that's a target or something like.
Hell no.
Okay. So, like we said, tangent is sine over cosine, and then from my unit circle, I have y and x, right?
Yeah.
So I'm gonna have to do those together. Okay. So now I'm gonna explain more when we get to that. So let's take a look at what we got here. Now, exact value of sine 75. The difference when I would say exact, pay close attention. If it says exact, that means I need to have one of those fractions with a radical plus or minus another one, right? If it was approximately, what do you think I should do if it said approximately? Take a guess. If it said approximate or approximately, you can put that in the calculator. The calculator will give you a decimal approximation of what we're looking for. Okay, so that's an important word to look at. So sine of 75. Now, for this right here, it's going to be sine of what two numbers?
45, 30.
Right? So for this case, it's going to be sine of 45 cosine of plus times sine 30. Very good. So now that I have that, right, where did I get all those things from?
Unit circle.
Yep, I'm going to get them from the unit circle. So everyone should have that out in front of them. Okay, your unit circle should be in front of them somewhere. So sine 45 is going to give me my rad 2 over 2 times cosine 30 plus, very good. Put it together, and I'm going to get rad 6 over plus, and my final answer,
Rad 6 over 4 plus rad 2 over 6. So the whole thing is going to be over 4.
whole thing over 4, like that, right? Okay, I knew what you were saying, I did. Okay, so the whole thing is going to be over 4 because they all have a common denominator of 4, right? Okay, so that's what I'm looking for. Now, what is another possible answer I could have that would be acceptable?
Rad 2 plus rad 6.
Rad 2 plus rad 6 all over 4. Okay, it's the same thing. It's equivalent to the answer, but you might have chose different numbers. You might have chosen a subtraction instead. You might have chosen, what else could I use to get 75? 120 minus 45? Would that give me that?
Yeah.
Yeah, okay, it would. So now let's move on to the next one. So the next one, I believe, is a tangent problem. So now, being a tangent problem, we've done this so many times that I really think at this current moment in time, you should know the degree measure for 7 pi over 12. What is it? 105, right? We've done it a lot. It pops up a bunch in the homework. So this is 105. So we're going to convert it to degrees first. So we're going to say tan 105. All right? It means the same thing. So that's going to be the tan, right? What is the formula for tan?
Y over X, or sine over cosine.
Okay, so it's going to be tan, hold on, of, what did we say it was?
Sine over cosine.
60. Very good. Okay, so this is the same as what we had for our warm-up today. So tan of 60 plus 45, that's a good start, right? So now we clearly have to identify, that's what I did there, identify, what is my A? 60, and my B is? Very good. So now I'm going to use those to actually move on with this. So now, given this, it's going to be tan A. What goes next? Plus or minus?
Plus and b.
Plus tan of 45 all over what
1 minus 10 a.
here let me back up, so because I think I'm losing people here. Okay, so tan A plus B is tan A plus tan B all over 1 minus tan A times tan B. Okay, now you don't have to memorize this, you will have it on your formulas. So 1 minus tan A
60.
I know. I just realized right there I wasn't actually putting in my numbers yet.
Okay, I'll go.
Sorry. Notice that. Okay. 60, and then it's tan 60, tan 45. There we go. Okay. Now, for this one, we're going to have a little bit of space. Tangent is complicated. The reason why tangent is complicated is because of the ratio y to x. So as we write tangent of 60, I'm going to be sine over cosine. My sine value is at 60, rad 3 over 2 over, what's the cosine? 1/2 plus. What is tan 45? What's the y? Very good. Rad 2 over 2 all over rad 2 over 2. That's the numerator. The denominator here. 1 minus. Same thing. Tan 60 comes out to be rad 3 over 2 over 1/2 times rad 2 over 2 all over rad 2 over 2. Okay, so before we move on to the next page, I'm going to actually clean this up.
Is that 2 over 2?
Yes, it's rad 2 over 2. So, do you have the unit circle out in front of you? So, from 45, if you're looking at 45, the sine value is rad 2 over 2, right? And the cosine value is rad 2 over 2, right? So eventually, very good, it's going to equal 1. This whole thing is going to be equal 1. But before I get to that far, I'm going to take a look at this left number right here. So the tan 60, I have a fraction over fraction. So whenever I have fraction over fraction, I need to do what?
Reciprocal.
Multiply by the reciprocal, right? So I'm going to go off to the side over here. So it's going to be rad 3 over 2 times 2 over 1. Very good. So 2 over 1, which just gives me rad 3. Okay, that's going to clean up that. So this whole thing cleans up a lot. So this first fraction is just going to be rad 3, right? Rad 3 plus, I have to have the 1. Right here, plus 1 here, right? Because for the tan 45 is 1, isn't it? Okay, so there's my 1 over 1 minus rad 3 times 1. Okay? Rad 3 times 1 is just what? Rad 3. That's important. I need to have that, okay? So I'm gonna move this over to the next page so I don't cram it all into one little space right here. So rad 3 plus rad 1 over 1 minus rad 3.
How's this gonna help us?
Hmm?
What?
Are we gonna use this
So we said it was, what is it? Rad.
3 plus 1 over 1 minus rad 3 times 1.
Okay, so rad 3 times 1 is just the rad 3. So I don't actually need to write that one anymore. Now, let's go to the word of the day. This was a previous word of the day. Okay? It's what? Conjugate. Very good. Conjugate. Now, this is going to be my answer. What you see up there is the answer. Okay?
Square thing.
It is the answer. But what is the problem with this thing right here?
There's a
Thank you. Radical on the bottom. I can't have the radical on the bottom, right? Very good. I have to rationalize. But because the bottom isn't just a radical by itself, it's not just a radical 3 on the bottom, it's a 1 minus radical 3. So that's a binomial. It's two terms connected by an addition or subtraction. So from there, I have to actually deal with a binomial. And to deal with that binomial, I have to multiply by the conjugate. Now, remember, that's the word of the day. Try and use it in a sentence at least once today. Okay? So, now, so when your friend gets out of jail later on today, okay, and you have to go pick him up because he was being dumb, okay, and you so you give him a ride in your beat up car, and then you have to tell him, conjugate nothing.
What's the word?
I tried, okay.
Wait, what's the word?
Conjugate. Conjugate. So like a con, someone was in jail. It's a con. You get nothing. Conjugate. Okay. Anyway, all right. So the conjugate of this. Now, for someone that was actually paying attention the other day, what would the conjugate of this thingy be? Starts with 1. I heard it. 1 what? Plus, very good. Rad 3, very good. 1 plus radical 3. That's what I'm looking for. Now, this is called the conjugate, okay? The 1 plus radical 3. But I'm multiplying by the value of 1. If I multiply anything by 1, it's going to get the same thing, but it's going to look different. Because when I do this right here, just the right-hand side, it's the same on top and bottom. So that's value is 1. So that value right there is 1. So when I do my multiplication, I have a binomial and a binomial, so I have to do my distribution on this. Okay? So for this right here, I'm going to have, it's going to be rad 3 plus 1 times 1 plus rad 3 over 1 minus rad 3 and 1 plus rad 3. So when you're multiplying binomials, they have an acronym for it. Okay, they have an acronym for it. So you multiply the first, the across, inner, and last. So I'm trying. Okay, I'm trying. Now, let's go through and do the distribution here. So I'm going to distribute this. So first is here. That gives me rad 3. Okay, all the way across is rad 9. But what is rad 9? 3, just 3. So it's positive or negative? Positive 3. So inner. 1. And last. Plus rad 3, right? Okay, all over. Now we're going to do the same thing on the bottom. And this is where the magic has to happen. So when I fail this, so first, it's going to give me 1. Okay, all the way across. Positive, positive. Positive. Rad 3. Inner. Negative rad 3.
Minus 3.
Trash now.
Wait, try going the other way. No, like the other way, like right leg.
Okay, so minus rad 3, and then my last.
Minus 3.
Okay, minus 3, very good. Because rad 3 is rad 9, the square root of 9 is just 3, and it's a negative times a positive, which gives me a negative.
Now we have 1 number.
But, like I said, this is where the magic happens. The magic is happening right about here.
Oh, that's what it crossed out, right?
It cancels.
Oh, cancel that.
Yeah, it cancels, it's gone. So it's going to be plus rad 3 and minus rad 3, so together it goes away. That gives you 0 right there.
Alright.
So that whole thing is 0. Okay, that whole thing is 0. So now I'm going to be left what's on top. So on top, start with my, okay, my
Radicals.
not the radicals. I'm going to start with this first. So this is going to be my constants. So 3 and 1 gives me
4.
Very good. So I have 4. And how many radical 3's do I have? 2. So I'm going to write
Rad 3 squared.
2 rad 3.
Alright.
If I was to multiply them together,
Would it be squared?
that would be squared. But since I'm just adding them, I'm treating them like variables. So they're going to just tell me how many of those I have. Okay, so I have 2 rad 3's. Okay, over. 1 minus 3 is?
Negative 2.
-2. Okay, now this is the part right here where a lot of people actually were messing up last time we actually tried to do this. Is there a common factor of the whole thing?
Yeah.
What is it? 2, right? Every single term right here has a common factor of 2. Yeah?
Yeah.
So I identified that. Now it's time to take it out. So I'm going to divide it out. It's called factoring it out. So I'm going to divide that. So there's a common factor of 2. So I'm going to take that out. What's 4 divided by 2? 2. Now plus, what's 2 divided by 2? 1. So it's going to be just 1 rad 3, isn't it? So rad 3 over -2. Now I have factored it out. So now it's all the way out of it, right? Now I can do this thing where I'm actually cancel. So I have a 2 out front here and a 2 down here. So it's going to give me what?
Negative.
That's just going to give me a negative now, right?
Yeah.
Just still have to deal with that negative. So my answer is going to look like this. So the negative is going to go out front. So it's going to be a negative. And it's going to be 2 plus rad 3. So there is my answer. That is 100% correct. The only thing that you could do different if you had, okay, you did it a different way and you just put the negative back in, which would be equivalent answer, same thing. So it would be a -2 minus rad 3 is also the same thing. So both of these are the same thing, and they're both correct. What part? Can't just say I don't get it and just sit there and stare at me awkwardly. What part?
I guess it was pretty easy until the blue part.
Till the blue part.
The fail part.
The distribution part?
Honestly, the first part.
What being the first part?
Like, I understood where you turn tan into the numbers. That was it.
Okay, I turned tan into the numbers, right?
Yeah.
Okay, so now we know when you have a fraction over fraction, you can't have that, right?
Yeah.
You multiply by the reciprocal, and that's what we did over here, right? So I multiplied that by the reciprocal. So now, when I multiplied that by the reciprocal, because I'm dividing a fraction, right? I multiplied that by the reciprocal. So now this whole thing right here turns into just rad 3.
Okay.
So I replaced this with rad 3. On the second part right here, I have rad 2 over 2 divided by rad 2 over 2. So if you have the same thing on top and bottom, what happens? It cancels out and you're left with just 1, right? When you have same on top and same on bottom, that's going to cancel and give you 1. That's where we get there. So now for my other, on my denominator, 1 minus, I have this, which we already said is rad 3, right? So I replace that with rad 3 and times, because it's multiplication, times 1, which came from there. Okay, but 1 times anything just gives itself, right?
Yeah.
So like 1 times 5 would just give me 5. And then 1 times rad 3 just gives me rad 3. Are you a little bit better there?
I'm good. Yeah.
To there?
Yeah. No, I'm good. I understand.
Okay, now, so someone else had an issue with this over here. Fail? Okay, now, right here when we're doing this, we're multiplying, right? When we multiply by the conjugate, I'm multiplying a binomial, which is 2 terms, times another binomial, which is also 2 terms. There's a pattern for this. So I did it like this. So it's the first one times the first one. There's my first and first. Okay? I multiply all the way across. All the way across. So now it's from my rad 3 to the rad 3. So that's all the way across there, which just gave me my 3. Because the 3 times 3 is 9. So and rad 9 is just the 3, right? Now my inner 2. So my inside 2 together. 1 and 1 gave me just the 1 when I multiply those. And then my last 2. My last 2 is just going to give me my rad 3 here.
So you know how you did the rad 3 plus 1 over the 1 minus rad 3? So if it was like a positive...
If this bottom piece was a positive, this over here would have a minus. Does that make sense? Yes, top and bottom, because when I do that, I need to multiply by 1. I'm not changing the value. Okay, multiply by 1, I'm not going to change the value. I'm just changing the way it looks. Okay. All right. Hopefully, help you guys out. You guys already got the homework for this. So I will be here after school. Don't forget, like and subscribe. Comment, 100 views.